Hello and welcome to our today's lesson, that is the mathematics lesson. We are continuing to do this particular topic on the length, area, surface area and volumes. And as we said earlier on, this particular topic is still under the broad branch of the measurement and geometry. In the introduction, we were able to look at how we can be able to calculate the surface area and the area of different particular solids, or in this particular case, the figures, like the area of a circle, the area of a particular rectangle, the area of a square, etc. Today we want to look at how we can be able to find perimeter and area of composite shapes. It's important for us to understand at this particular juncture that composite shapes are simply a figure that consists of more than one shape. That is, composite shapes are made up of more than one basic shape. So that in this case, if we are talking of a rectangle, for instance, we do not have a rectangle alone. We might have a rectangle plus some other figure that is attached to it, and it can be either two or more than that. Now, for you to be able to find the perimeter and the area of those particular composite shapes, you need either to add, that is addition, and or subtraction is used in finding measurements for the composite shapes. So we can either add or subtract. Like in this particular case, if you are to get the perimeter around this particular figure, you will take the perimeter or the length of the straight lines. There are three straight lines. Then we have a semicircle. In this case, we will add. But in the case we will have an expression of that form, then we are supposed to maybe calculate the area of this particular figure. Then when you calculate the area of this particular rectangle, which is the side A, you must subtract this half a circle. So it involves either addition and sometimes subtraction for you to be able to get the area or the perimeter of those composite shapes. We are going to consider a number of examples on how you can be able to find the perimeter and the areas of the composite shapes. Example 1. Find the perimeter and area of this composite shape. Rounding your answers to 2 decimal places. We have a figure that is in the shape of a rectangle, then we have a semicircle attached to one of its sides. So that is the perimeter, the rectangular part. It has a circular part that has been attached to one of its side. This is the circular part, then that is the rectangular part. We are told that the length of this rectangular part is 17 centimeters. The width is 14 centimeters. And we understand that for a rectangle, two opposite sides are always parallel and equal. So in this case, this side and this side are parallel and therefore equal. Again, this side and this side are going to be equal, and at the same time they are going to be parallel because they are the opposite sides of a rectangle. Now, given that that is 14 centimeters, this will dictate that this particular width of this other side will also be 14 centimeters. Given that this is 17 centimeters, this shall also be 17 centimeters because of that aspect of being parallel and equal on the opposite sides of a rectangle. Now the question here, we are supposed to find one, the perimeter of this particular shape, and two, we are supposed to find the area of this particular composite shape. Now we are going to divide this particular shape into two areas, that is part A and part B. So that part A encompasses the part with the semicircle, and part B encompasses the part with the rectangle. Now in case you want to get perimeter, let's assume we want to begin from this particular point, then you'll have to move for the three straight lines, that is 17, 14, 17. Then at this particular point, you have to go round the semicircle. So that means we need to get, for part A, we need to get the distance of this circumference of this particular half circle, then we add to the distances along the straight lines. So in that case, part A, perimeter will be given by, we understand that circumference is normally given by pi d in case it is full or a full circle. But in this case, because it is a half, we are going to have a half pi d plus, we are having twice the length, that is this distance and this distance. Then we add the width, which is 14 centimeters. So when we make that replacement, we shall have a half multiplied by 22 over 7. The diameter is 14 plus 2 multiplied by the length, which is 17 centimeters, plus the width, which is 14 centimeters. 2 goes there once, 2 goes into 22, 11, 7 goes there once, 7 goes into 14 twice. So in the first part, 11 by 2, it will give us 22. So that means that this particular distance, or the half of a circle's circumference, is 22 centimeters. So we shall have 22 plus 2 multiplied by 17 is 34, added to 14. This will give us that when you move around this particular composite figure, you'll be able to cover 32 plus 34, which will give us 56 centimeters added to 14 will give us 68 centimeters. When you add 22 plus 34 plus 14, it gives you 70 centimeters. So the distance around this particular figure is 70 centimeters, which includes going a half distance of the circumference added to the 3 straight lines of this particular rectangle. Part B requires us to find the area of this particular composite shape. Again, we're going to divide or work out the area in two parts. The first part is this part of the semicircle, and then the second part is this part of the rectangle. We are supposed to find the area of A added to the area of B for us to be able to have gotten the area of this particular composite shape. Therefore, area of A will be given, because it is again a half of a circle, it will be given by a half multiplied by pi r squared, where r is the radius of this particular circle. And given that the diameter from here up to here is 14, that means the radius is going to be a half of 14, which is 7 centimeters. Added to the area of this particular B, part B, which is a rectangle, and the area of a rectangle is normally given by length multiplied by the width, where our length is going to be 17 centimeters and our width is going to be 14 centimeters. This will give us a half multiplied by 22/7. The radius is 7 squared plus 17 multiplied by 14. Now 2 will go there once, 2 will go into 22 11 times. 7 there once, 7 into 7 squared will leave us with 17. So that means this particular part, or the semicircle, will have an area of 7 multiplied by 11, which will be 77 square centimeters, plus when you multiply 17 by 14, you get 238 square centimeters. So when you add it to 77, you'll get 315 square centimeters. Again, it is important for you to write the units of that particular measurement that is in question. If it is in if it is area, it's always the square of those particular units. If it is length, then again remember to write the particular units. So in an actual, that is how we can be able to find the perimeter and area of this particular composite shape. Let's consider another example. Find the area, example 2. Area of each of the following composite shapes. Part A, we are having a parallelogram we understand that two opposite sides of a parallelogram are always equal and parallel. Equal and parallel, which forms another square. We have a square that has been attached to it, where all the sides are going to be equal. And because this side will be equal to that side, will be equal to that side, will be equal to that side, and again the two are going to be parallel, the two are also going to be parallel. We are told that the height of this parallelogram is 2 centimeters, and that the length or the base is going to be 4 centimeters. We are told that this square has, or measuring 3 centimeters by 3 centimeters. The question is, we find the area of this particular composite figure. As we had introduced earlier, a composite figure consists of more than one shape. And as you can be able to see, we have more than one shape that has been fused together to form this particular shape. So this is a composite shape that consists of this part, which is a parallelogram, and this part, which is a square. Important again is that we should be able to recognize the different shapes and their names. So like in this case, this is a parallelogram, this is a square. And again, for us to be able to find the area of this particular composite shape, we need to find the area of this part A, which is a parallelogram. We need to get the area of this, let us call it part B, which is a square measuring 3 by 3 centimeters. So total area will be given by the area of part A plus the area of part B. And because part A is a parallelogram, we had given out earlier that area of a parallelogram is normally given by the base multiplied by the height. And in this particular case, because that is 4 centimeters, this other side will also be 4 centimeters. And that tells us that the base of this parallelogram is going to be 4 centimeters. Therefore, area of part A will be given by the base multiplied by the height. We add that one to the area of this particular square, which is measuring 3 units by 3 units, which will be given by length times the length, or width multiplied by the width. So in this case, we shall have the 4 multiplied by the height, which is 2, added to 3 multiplied by 3. This will give us 8 square units for the parallelogram plus 3 multiplied by 3, which will be 9. That will give us 17 square units or square centimeters for the area of this composite shape. Part B, we have a shape can be able to tell me which type of a shape is this. We also have this part which has been straightened up. That is 90 degrees. This is also 90 degrees. We are also told that the perpendicular distance from that particular point to this particular point is 2.5 meters, and that this distance is 3.0 meters, and that this distance from here up to there is 0.5 meters, given that also this one is 2.5 meters, the bottom, or this other figure. So again, if you consider this, we can be able to say that it's a composite figure. A composite figure in the sense that we are having two parts. It has this first part, which has been made in the form of a trapezia, and this other shape, which is in the shape of a rectangle. And therefore, for us to be able to find the area of this particular composite shape, we need to get the area of the trapezium part plus the area of the rectangular part. So total area will be the area of trapezia plus the area of the rectangle. Area of the trapezia is normally given by a half into A plus B. Those are the parallel opposite sides, A plus B, multiplied by the H, or the height, plus area of a rectangle will be given by the length multiplied by the width. So in this case, we're going to have a half. The shorter distance, which is A, will be 2.5 meters, plus the longer side, which is 3.0 meters, multiplied by the height between the two parallel and opposite side, which is 2.5 meters, plus length times width. The length of this particular rectangle is 2.5. The width is 0.5. So we shall have 2.5 multiplied by 0.5. So when you do that, you add 2.5 plus 3, you'll get 5.5. 5.5 multiplied by 2.5, you'll get 13.75 divided by 2, we shall get 6.875. We add it to 2.5 multiplied by 0.5, which will give us 1.25. So when that is added to 6.875, it will give us a total of 8.125 square meters, because the units were in meters, so that will be square meters. So for the composite shapes, you look for the area of the first shape, which is known, and it is a trapezia. Then you add to the area of the second shape, which is known to be a rectangle. And when you do that, you get 8.125 square meters. So this 8.125 square meters is the total area of this particular composite shape. Part C of the question, we now want to consider a case where we are going to subtract a particular known shape from a composite shape for us to be able to have the total area of that particular shape. Now we have a square and on this square of ours we have some parts that have been added. We also have some parts that have been subtracted. In this case, we are adding a semicircle there. On this part, we are eliminating a semicircle, and on this other part, we also eliminate a semicircle, while on this other part we add a semicircle. So we are supposed to find the area of this particular composite shape. We have added this one into the wall shape. And again, we have subtracted the two. And the square has a measurement of 4 centimeters against 4 centimeters, and that the distance from here up to here is 2 centimeters. That's 2 centimeters. This is 2 centimeters. That is also 2 centimeters. Now, for us to be able to find the area of this particular composite shape, we need to find the area of this, and we find the area of this particular shape. So we have part A, let us call this one part B, then we have the part C. So there are 3 composite shapes. So for part A and part B, because both of them are semicircles, we can fuse them so that you can have one wall circle that has a diameter of 2 centimeters. So A plus B gives us a circle, and therefore area of A and B shall be given by pi r squared. That is the pi, which is a constant, multiplied by the radius of that particular circle. Then we need to get the area of this other part, which is a square. And because we are having these 2 semicircles eliminated, again, for us to be able to get the area of C, we need to get the area of the wall square. We subtract the area of these 2 circles. And again, because these 2 circles are the semicircles are the same, they are going to be fused into one, giving us one semicircle. And therefore, for us to be able to get the area of part C, we need to get the area of the wall square. We subtract the area of this, which will give us one circle. So area of C will be given by length squared, that is length by length. Then we subtract pi r squared. So in this particular case, total area shall be the area of A and B plus C, that is area of A plus area of B plus area of C. But we already know that the area of A and B is pi r squared, so we shall have pi r squared added to the area of C, which is L squared, length squared, subtract pi r squared. And we can now be able to make our work easier because we have pi r squared, they'll eliminate one another, leaving us with L squared. And therefore, the area of the wall shape has been reduced to 4 multiplied by 4, which is the length of the square, which will give us 16 square centimeters. So there's no need for you to make the calculations of this, because you can easily be able to eliminate them in the preliminary stage. Alternatively, if you wanted to attack this particular question, you see this shape, which is a semicircle, is equivalent to this one that has been chopped out. So if we can decide to return it here, we choose to return this one there. Then again, the total surface area will be the area of a square, which will still be 4 by 4, which will give us square centimeters 16 units. Part D, we again have a shape which is in the form of a rectangle. So we have a rectangle, then which has been chopped from the inside, and we have an additional part there, also there, which are measuring 2 centimeters by 2 centimeters. And we are also told that this side is equivalent to this side, which is 2 centimeters, while this side is 3 centimeters. We are supposed to find the area of this particular shape. So as you can be able to see, we need to find the area of 3 parts here. This is the first part. Let us call this one the second part, and this is the third part. Now, for you to be able to get the area of the first part, we can fuse it to the area of part B. This is a semicircle. This is a semicircle. They have got the same diameter. So when fused together, they'll form one particular circle. Therefore, area of A plus area of B shall be pi r squared. Now, for you to get the area of C, initially it was a full rectangle, but a half a circle which has a diameter of 3 units has been chopped off. So for us to be able to get the area of this particular part C, you need to get the area of the full rectangle. We subtract the area of this particular semicircle. So it will be given by length times width. We subtract by r squared. In this particular case, the r squared, or the radius, is not the same as the radius of the first circle. So total area of this particular composite shape will be given by the area of A plus the area of B plus the area of C. Area of A will be given by 22/7 multiplied by the radius squared. Because the diameter is 2 units, that means the radius is going to be 1 unit. So that will be 1 square of 1 plus area of C, which will be given by the length times width, that is 2/3. Here we are subtracting this particular semicircle. I forgot that should have been a half. So that will be given by a half times 22/7. The radius of this particular place is a half of 3, which is 1.5 square centimeters. So in this particular case, this first part will give us 22/7 plus 2 multiplied by 3, that will give us 6. Then a half multiplied by 22/7 multiplied by 1.5 squared will give us 3.5357. So when subtracted from 6, it will give us 2.4643. When added to 22/7, that will give us 5.6071. This has been rounded off to the nearest 4 significant figures. So that will be centimeters squared. So in short, this is how we can be able to find the areas and even the perimeters of some composite shapes, where you need to either add or you need to subtract a particular non-figure from the composite shape for you to be able to obtain its area or the perimeter. We are told that using exact values, find area of the shapes, find area of the shape given below. So we are having a circle which has a hole that has been drilled into it. We need to find the surface, the area of this particular part that has been shaded because a hole has been driven into it. We are told that the radius or the bigger radius is 21 units, and this hole is 7 units or 7 centimeters in radius. Now for us to be able to find the area of this particular shape, we need to find the area of the wall shape. We subtract the area of this hole that has been made for us to be able to remain with the area of this part that has been shaded. And we understand that area of a circle is normally given by pi r squared. So in this case, we shall get the area of the bigger circle, which shall be pi r squared. We subtract the area of the small circle, which shall be given by pi r squared, where small r represents the radius of the small circle. We can be able to factor out pi, so that will be pi into r squared, subtract r squared. This will give us 22/7 multiplied by 21, subtract 7, and that is centimeters. So this will give us 21 squared multiplied by 7 squared. That will give us 22/7 multiplied by 441, subtract 49. So this will be 22/7 multiplied by 392, which will give us 1,232 square centimeters. Therefore, the total this will give us 1,232 square centimeters as the total surface area of this particular shape place that has been shaded. So this particular example brings us to the end on the discussion on how can we be able to find the area and perimeter of composite shapes. Let us look at how we can be able to find the surface area of prisms and pyramids. Prisms and the pyramids. Now, prisms and pyramids have different formulas for calculation of maybe their total surface area in the aspect that prisms and pyramid normally have different perspectives in terms of their shapes. Now, for you to be able to find the total surface area of prisms, for instance, you need to be able to understand the different shapes that makes or that consist those particular prisms. And we can have rectangular based pyramids or prisms, triangular based pyramids or prisms, and so forth. So it is also important that you understand those particular shapes. We are going to consider a number of examples on how we can be able to find the surface area of prisms and pyramids. Find the surface area of the following solid shapes below. So we have the first shape, which is a prism. Prisms don't have sharp ends. So this particular prism is measuring 3 centimeters by 5 centimeters by 2 centimeters. And this is in the form of a box that has been closed. So we need to find its surface area. And you can be able to see that from this particular box or from this particular prism, it has got some sides which are going to be equal. Like for example, if you consider this front side and the back side that you cannot be able to see the other side, then this side is also equal to this particular other side because the measurements are the same. Then the base and the bottom and the top are also equal rectangles. Now for you to be able to find the area of this particular solid shape, you need to find the different areas of those particular bits. So like in this case, we need to get the area of this face multiplied by 2. That will be 2 multiplied by length times the width plus, we come to this side, there are 2 again, this side and the other side, so that will be 2 multiplied by this shall be the breadth multiplied by the width plus the base and the top, that shall be twice the length, which is 3 centimeters, and the breadth. So in this case, we're going to have 2 into length times width. That will be 3 multiplied by 2, because if this is 2, this is also going to be 2 centimeters, plus 2 multiplied by 5 by 2, that is the breadth and the width, plus 2 multiplied by the length and the breadth, that is 3 by 5. Because if this is 5, this is also going to be 5. So we have the top and we have the bottom. So this is going to be 2 multiplied by 6, which will give us 12. This is 10 multiplied by 2, which will give us 20. This is 2 multiplied by 15, which will give us 30. Therefore, when you add 12 plus 20, you get 32. 32 plus 30, you get 62. The units are square centimeters. Important to note that sometimes you'll be asked that this particular box is open. So when you're told it is open, then you don't need to multiply the last part by 2. You only need to get the base, which is 3 times 5. The second shape is in the shape of a prism. The second shape is in the shape of a pyramid, which is square-based pyramid. And this particular square-based pyramid, the square measures 2 units by 2 units. So that is 2 units against 2 units, and they're given in terms of meters. Then this particular height of one particular triangle, we are told, is 3 meters. It's also important for us to draw the net of this particular solid before we can be able to proceed and know how many triangles do we have and what other figure do we need to add. Like in this case, from this particular point of view, you'll understand that we're going to have 4 different triangles because it is a square-based pyramid, and a square-based pyramid has got 4 sides. So each side has a triangle that has been attached to it. So in essence, we have got 4 triangles which are measuring the base 2 meters against the height, which is 3 meters. So if we were to draw the net of this particular figure, we'll have 4 triangles on all the sides. Each triangle is measuring or has a height of 3 units, and the square itself is 2 by 2. Now for you to be able to get the area of this, you need to get the area of these 4 triangles. You also need to get the area of this particular square. So area, or total area, shall be given by area of 4 triangles plus area of the square. Now for you to get the area of one triangle, you need to get a half multiplied by the base multiplied by the height. But in this case, we are going to have 4 of them because we have 1, 2, 3, 4, plus length squared, which is the area of that particular square, which is in the middle. So this shall be a half multiplied by the base, which is 2, multiplied by the height, which is 3, all this multiplied by 4, plus 2 multiplied by 2. So this 2 will go with that, leaving us with 3. 3 multiplied by 4 will give us 12 square units, plus 2 multiplied by 2 will give us 4 square units. So that tells us that this total surface, total area of this particular pyramid is going to be 16 square centimeters. Final example on how we can be able to get the total area of a prism. We are told find the area of the shape below. We have this side being a right angle triangle, giving rise to that particular shape. So in this particular shape, we have to redraw this particular shape into its net so that we know what figures or what shapes are we in consistence with. So we'll draw from the base. We are going to have the rectangle, the rectangular part. The rectangular part has been attached to the 2 triangular parts, this particular part and the other part. And mark you, these are right angles. Then when you open this side and you open the other side, we're going to have those particular shapes. Now we are told that this is 3 units, that is 3 units, and that our square in the middle is measuring 4 units against 7 units. So that means that that is 4, this is 4, this is 4, that will be 7, that will be 7, 7, 7, and that part is going to be also 7, and this other part is 4 units. Now for you to be able to get the total area of this particular figure, we need to get the area of these two triangles added to the area of the 3 rectangles. We have 1, 2, 3 rectangles, and we have got 2 triangles. So total area will be given by the area of 2 triangles added to the area of 3 rectangles. Area of a triangle is normally given by half, base multiplied by the height. The base in this case is 7, the height is 3 units, plus the area of the 3 rectangles, which are measuring 4 by 7, that will be 4 by 7, and because they are 3 in number, we multiplied by 3. So 7 by 3 will give us 21. 21 divided by 2 will give us 10.5. We add to 4 by 7 will give us 28, multiplied by 3 will give us 84. And these are square units. So this will give us a total of 94.5 square units. This is how we can be able to find the area or the total area of a given prism. Always ensure that before you proceed, first come up with the net of that particular prism or the pyramid before you continue to either add or subtract the other shapes which are known. This brings us to the end on how we can be able to find the surface area of prisms and pyramids. Thank you.